Hello everyone and welcome. So in this video we'll be creating the scene step by step. It will be a good chance to learn new things about Houdini if you're kinda new to it. I will try to make it as beginner friendly as possible. We won't touch in many advanced topics like Vex and other things, but hopefully you'll get away with some new techniques. So yeah, let's get started. So I just saved the new scene and we will start by dropping a geo container and with the box, which will be our main object for the perfume bottle. So let's give it a size of 2 in X, 3 in Y, and also give it a subdivision. No, in this case we will leave it like this. Now we will poly bevel it, so pretty common thing in many other softwares. So we will bevel by 0.15 and we can leave the divisions like this and do another bevel to those edges and we will bevel it by 0.023, so a small size and 3 subdivisions. So we get something like this. Now we will create an object here in the front part. So for that, let's create another box. And let me see which values I used. So size of 1, 1, and 0.02 in the z-axis. And now we will group an edge ring in here. So this inner edge ring, so we can bevel it. So let's go for edges and disable the base group, and here in the edge length we can introduce a small value, in this case in the max. So let's see, this will work. Now we can bevel it and we will bevel it by about 0.03, so 0.03, and select those edges and introduce some subdivisions. Now we will bevel it again, but this time we will ignore the flat edges and maybe let's say 30 and 3 divisions and a distance of 0.00. So as you can see, if we disable this, it will bevel everything. It's just an angle threshold. So now that we have this, we can match size and align it to this object. Let's click in here to preview, control click, and let's do the alignment on the Z by the min to the max. So the min position in Z of the small cube will align with the max of the perfume bottle. So we also want to move it up, so we can add an offset in here, so 0.55. And now we want to create some screws, let's say. So for that, I'm gonna start from here on the box and create a blast. And we can disable this and let's blast the primitive 0, so the front one. And we can scale it down. But for now, let's create a sphere. And in this case, I'm going to use a lab sphere generator, which will give us a quad sphere. We don't need UVs, but let's keep it like that. And now we want to cut it, but on the z-axis. And we also want to scale it a bit in on the z, so by 0.8. And let's also polyfill it, because we will use some VDB operations and we need filled polygons. So single polygon will do fine. Now let's copy 2 points. So we'll copy geometry to these 4 points we have in here. And this is too big, so we can adjust the scale with an attribute adjust float. And the p scale I used was 0.04, so 0.04. And let's merge this. And we actually need to do this after. So in this case, as you can see, it's a bit outside, so we need to scale it in. We can do this with the primitive properties and do transformation. And in this case, I believe I used 0.9, so just scale it a bit in. So as you can see, we're just scaling it. Now we can merge everything. Oops. And we have our base done. So now we want to break the objects into different pieces so we can have that broken look I showed you in the beginning of the video. So for that we will use RBD material fracture, which will break these into pieces. Just wait a little bit, and we don't need the second breaking or the second fracture. Right now we have 5-point scatter. We can play with the seed, not the seed, sorry. Scatter seed, yes, scatter seed. And we will start to have some breaking. And I can place an exploded view and just a little bit. And we start to have that effect. Then we can introduce some edge detail. So if we go to the detail and play and introduce edge detail, in this case I'm going to reduce it to 0.03 and increase the noise height so it has a bit more effect. But now it's too much. We need to increase the element size, which is the noise frequency. So something like this. But here's the thing, I don't like this particular layout or this particular scatter or distribution of pieces. So there's one option in here that you can introduce your own points, so input points. So we could always introduce a scatter, and let's say 5 points, and we connect it to the last input. And we need to remove scatter points, so 0, and introduce the input points. So this is a bit better, but in my case I really want to warp direct the placement of the points. So I'm gonna use a custom node, place point on geo, and this enables me to place a point or drag it or delete it, as you can see. I'll make sure to make these available on Patreon if you guys want to grab it. But again, you don't need it. You can just use a scatter and do the RBD material fracture. I'm just gonna be picky about the points and place them where I want. So I will place one in here, another one in here. Let me see. I have one in here, one in here. Yes, and then I have another one in here, one here in the middle. Let's see, and another one on the back. Right about here. I believe that's 6 points, so actually I have more. I have 2 more in here, so one at the bottom, and one at the top in here, and I believe that's out. But there's one more. Let's see. So back to, maybe in here. So one in here. So sorry about this, it's just I want really to control the placement of the damage. Let me see if this is even similar to my setup. And I guess it's similar enough. But maybe I can drag, let me see. I can drag this one a bit down, so let's see if that fixes it. I guess. Let's keep it like this. So, okay, maybe let's drag this one down. Oops, let's drag this one down. And this one to the top. Yeah, that fixes our issue in here. So, let me see. Do we have this in here? So we will break one in here and another on the back. So let's see. Maybe let's add another point in here. And we can blast. So now let's make sure we select. And now we can set here the group select and go for attributes and name. Now we can select by name and press 9. We can select fully contained geometry. So I'm gonna select these and these in here. I'm just gonna delete those. And maybe that one too. So something like this. We also need to select this one. So maybe something like this. It's not exactly the same as I had it, but this will do for now. Now we will use this exploded view. Let's reduce it to 0.01. So something like this. Now we will loop through these pieces and do some geometry operations like remesh, VDBs. So it's better to loop them. It will be more optimized and actually do a better job of creating the nice details we want. So let's do that next. So let's create a for each named primitive. So this will iterate over the different pieces we have, as you can see, and we can do operations on them. And at the end we will compile this loop, which will be a bit more optimized. So the first thing we're going to do is to remesh, and let's try that to see some possible problems. So as you can see, we are remeshing with the same size to every piece, but that will cause us issues because on the smaller pieces they will start to disappear, although it's creating these nice effects on the edges. That's what I'm looking for. But we need to do this remesh with some algorithm in mind, let's say. So we need to remesh it according to their size. So for that, outside we will measure the area. So we will measure the area per piece and set the name. And now we will need to promote to a point attribute. So attribute promote from primitive, from area, the area from primitive to point. We don't want to delete the original, or we want to delete the original, sorry. And do another attribute promote, and we will need the max and the min values of the area so we can fit them to a new range. So let's promote the area from point to detail and set minimum, change new name and set it to min area. Now let's duplicate this, set to maximum, and we will set it to max area. So we now have those attributes, so the max area and the min area. And we want to create a wrangle. And we will just use a very simple function, which is the fit function, which will change the range of our values. So let's assign an attribute called target size, and let's use the fit function. And what we want to fit is the area, and we want to fit it between the detail, incoming geometry, and mean area. So we want to fit it between the mean area and the max area. So these are the old mean and old max, and we want to fit them to, oh, sorry, we want to fit them to mean, target area, and the max target area. Target, not area, sorry, size. So size, which will be the target size on our remesh. And we just need to close brackets and finish our sentence, our code. And I found some values that work well, which will be 0.1, 0.01 and 0.1. And if we look at the spreadsheet, we will start to see we are fitting between 0.01 and 0.1, as you can see. So now if we go to the remesh, let's isolate one piece and say point, and can be any point. So incoming geometry, any point, I will just pick 0. And how did we call it? Target size. So let's copy this and paste it in here. And the component is just a float, so it will be 0. So 0.00 target size 0. Value. So let me check what am I doing wrong in here. Point. So have target size. It's on the points, right? On the points. 0.0, 0.0, target size component 0. Oh, I believe we need to reset this, and now it's working. Sometimes when working with loops can be complicated. So not sure why it's giving me that warning, but as you can see, it's remeshing in a more consistent way, where the smaller pieces get enough divisions, and you can play with the range and feed them with other values. But I'm looking for this breaking in here, as you can see, which will create some nice effect. Don't worry about the shading issues, because we're about to VDB this out and it will solve that. Speaking of VDBs, we will also need a VDB size similar to this one. So let's copy this wrangle and take care of it right now. So let's go for VDB size, and we will change it between 0.003 and 0.008. So these were some values I found useful, or that worked really well. And let's do some edge breakup. So really simple in here. So let's duplicate this remesh, and in this case we will multiply it by 2, because we want it a little bit bigger. we will do an attribute blur, and let's go with a smaller size, something like this. So we just want to round it a bit. Let's do a peak. I'm copying some values, but this might not work because my scene is a bit different now. We will pick it along the normals, and let's do a boolean intersect, and you can see we start to get some damage. Let's maybe play with this and get something interesting. So something like this. And let's see how it works. So it's working fine. We're creating some damage, as you can see. And what will we do next? Next, we will, for now, let's create an attribute. Why is this showing time dependent? So let's reset. Did I introduce something in here? Sometimes Houdini does strange things. Now, we have an inside group from the RBD fracture. As you can see, if I place these on groups and go for inside, you can see we have these inside pieces and we will need it. So let's create an attribute from that inside group and call it that inside is equal to 1. And this will just create this mask that we can use in our next step, which will be the VDBs. So now let's create those VDBs. So I'm gonna create a VDB from polygons. And the idea here is to give some details to the inside pieces. So I'm gonna create a VDB, and in here I'm gonna copy this expression, but we created that attribute called VDB size. So VDB size, and it is at the end. So this will be based on the size of our geometry, and we will use world scale and fill the interior. And we will pass an attribute, which is the inside, that we're going to use to mask out the inside pieces. Let's call it inside, which is fine. And now we might start to see an halo around the pieces. So we can do is set the visibility and hide the inside. So maybe it's not so visible. Let me reset this. Okay, it's not so visible, but believe me, this will show an halo around the object, which is this mask we have in here, this attribute. So now we will create a volume VOP, and we will create some details. Let me just isolate one piece in here. So let's go maybe for this one, which has this inside part. And the volume VOP, it will be, it will be simple, but we have to create some nodes. So let's create, let me just check, did I call this density? No, density. And am I passing the inside? I guess. I can start to see. there's a difference there. So yeah, let's save it and create a unified noise static. Connect the position to the position. We will need a constant for the frequency, and to scale the noise we will use a multiply constant. And we will also need to fit the values, so fit range after the noise, and a multiply constant to scale down the effect. And to add it to our noise, we will use an add node and connect it in here. Now, this will be too much by default, so I'm gonna reduce it to 0.1, 0.2. So as you can see, it's shrinking down the mesh. And let's see what sort of values we will use. So I'm gonna start by setting the noise type to purling and change the repetition to 18. So now the next obvious step would be to fit the range, so we can start to increase this value. In this case I use 0.293, and I also reduced the effect quite a bit, so 0.03, 0.03, and let me see what else. I also introduced some fractal in here, so something like this, and you start to see the effect. It's better if we look at a converted version. So convert PDB and convert it to polygons, so you can see the effect. Now we have that attribute, so if we bind the inside attribute, inside volume, and where did I multiply it? The constant. So if we introduce a multiply in here and add this, as you can see, it won't affect this front part, and it will create the effect on the inside. Now, I also introduced some distortion to this noise, so let's do that. Let's create a turbulence noise and go for a sparse convolution 3D noise, because we want values between -1 and 1. Let's increase the frequency to 4, connect this to the position, and add it to the position of our noise, main noise. So this will just distort a bit, and you can distort more or less depending on your amplitude. So now let's copy this setup in here and duplicate it. And in this case, I want to change the type of noise, and also let me do something in here. Let me create a switch to turn on and off the noises. Connect this to the input. Let's set it to yellow, and let's disable it for now, and do the same for this one. But let's enable it and connect it to the end. So in this noise, we will change this to Worley Cellular F2 F1, so to create some dents, and the frequency will be really small, I believe around 2, so 2. And what else? I need to fit the range better and change this to 0.2, so to have more effect, as you can see, and maybe play with the fit range. In this case, I just reduce it to something like this, or in this case increase the effect. So this will be nice, and let's enable this. So enabling both. Now I'm seeing it's a bit too much too much distortion. Let's reduce the frequency and reduce this effect. So this can work a little bit better. And let me see if I'm forgetting something. I don't think so. So let's run this loop and see our result. I mean, I need to single pass. And this will take a while, as you can see, but in the end we will have a nice result. The thing is, this will take a while, so we need to compile it to be more optimized. So let's select the first node and create a compile block and connect this in here and enable multi-threaded. And of course we will have an error because we are using direct reference in this remesh and VDB nodes, so we actually need to use spare inputs. I have a video on the channel about that, which is named compile loops, something like that, how to compile loops. And I'm gonna add a spare input and connect this node and just reference -1 and do the same in here. So add spare input, reference this node -1, which is this spare input, and do the same in here. So add spare input and reference the node above and select -1. Let's see if now it's working. So it's compiling, and there you go. Now it's a bit faster. It's quite a bit faster in this case. So that's our loop done. Now we need to do the top part. So let's see. Let's do that next. So let's start with a box. We want to do the top part of the bottle. So with the box, the Y size of 0.3. And now we will bevel it. Let me see how much I did bevel. So about 0.08 and 3 subdivisions. No, in this case just one. We don't want it rounded, as you can see. And now we can add another bevel, but this time we want a distance of 0.006 and 3 subdivisions. So we have this nice smoothed result. Now we will create a tube. So let's reference this and create a tube. And in this case, I want a radius of 0.5 and I want end caps and reduce the height to about 0.4. Let's introduce quite a few subdivisions because we will VDB these out. And now let's match size so we can align it. And let's do max and min. Oh, not in the Z, on the Y. Max and min, yeah. Now we need a torus here in the middle, so let's create a torus. And I have some values for it, so a radius of 0.28 and this inner radius of 0.09. Let's also introduce some subdivisions, otherwise the VDB will have that low poly look. So let's match size this to this object, I believe. So yeah, in the middle. And now let's learn a new trick. Select this node, this one and this one, and I'll drag to create a merge. And this is our top part done. Now we will VDB this out. So VDB from polygons, and we'll go quite low, so 0.005 to have these nice details. We will also VDB smooth SDF to add a bit of smoothness, not so much, maybe just 2, and convert VDB. So we just want to unite the shapes so we have a single polygon, as you can see. Now we can match size this to this geometry, and in this case we want min and max and min and max. Yes, I was right. Let's merge these, and we have our initial shape done. Now the only thing to do is to do the stone at the bottom that you saw in the beginning of the video. So let's do that next. So now we will create the stone, and for that I'm going to create a box, and let's change the size to 2.5 and 1.3 in the Z. And now there's a node in Houdini called edge damage, and you can see this is a bit slow. Well, it was fast this time, but let's maybe increase this to 8. And as you can see, it's slow, but in this isolated object it will work really well because it creates very nice details. And if you want to put it in a loop, if you're iterating over geometry and creating this node every time, it will be really slow and I wouldn't recommend it. But for such a simple object it works pretty well, and I'm happy with the result. Now you can just align this to the initial object and call it done. I'm gonna go a step further and maybe show you some nice techniques, so if you want to stick around. So as you can see, this will create this uneven mesh that won't work for the next step, which will be a triplanar displace. So I'm gonna quad remesh it just with the Houdini one. And let's go for 100,000. And as you can see, we have some. I'm not saying this is the perfect topology, but it's well distributed and work well for our next step. So now we will select the faces on the sides because I want to add some details to them with some triplanar displays. So let's use a group expression. Oh, not group expand, group expression. And let's keep it on the primitives and say that, and so the normal Z component is bigger than 0.95. Let's see that. So this selects the front faces, and I also want to select the back. So let's do an absolute, and this now selects the back too. And we need to do the same. Let's go with this hand symbol and do the X. So this will be fine. Let's create an attribute and call it sides. Set it to 1. Let's visualize it and select the group 1. So this is fine. Now we want to blur this attribute because otherwise we will have an harsh transition. So attribute blur, and we will blur the sides. I believe I set it to 100. In this case, 200. 200, yes. Let's disable the visualization, and now we will create a triplanar displays. And I will be using these two assets from Megascans. Let me see if I can show you. You can just search for this one, massive layered rock cliff, and this rock cliff can copy asset ID. So is this one and this one. So if you can pause the video and search for it. So I'll be using those two textures. So if I triplanar displace this, it will be a mess. So as you can see on the edges, but first let's connect the texture. I have here already the file, so let's paste it. As you can see, it will be a mess on the edges, and I'm gonna instead do it in the color, as you can see, and displace it in a volume. So a bit on the experimental side, but I found it works a bit better. So let's change the texture scale to 0.4, and in this case I change the offset to 0.2 and 0.2. So this will be the first one, but we actually need to subdivide this mesh, otherwise we won't have enough detail. So let's go with the subdivide, and one will be fine, and this will give us a bit more detail. You can see our poly count is already a bit high, but if your computer can handle it, you just bypass that subdivide. So I'm gonna use the other one, and I'm gonna copy it to the color, an offset of 0.3 in here, and a scale of 0.2. So I will use those two textures. Now in a point VOP, I'm gonna combine them. So in this case, I'm gonna use the composite node. First of all, we have the CD of the first input, which is the color attribute, as you can see in here. And we also have another CD in here in the input 2. So input 1 we have here the CD, but for the input 2 we need to import point attribute and connect it here and import CD, which is color diffuse, I believe. Then we need a composite node, and we will composite between first this one and this one, and let's connect this to the CD, and we need this, change this to overlay, so it will mix both textures. But in this case I reduced a bit the second texture to 0.7, but we don't want to actually copy to the CD. In this case we just want a constant, set it to white and connect it to remove the color, and we want to bind export, so we want to export the attribute. In this case, before that, let's do it this. Let's do a vector to float, because we don't want actually a vector, we just want a single channel. So let's bind export. And at this point you are probably really bored, because I keep working on this. I should have called it done already, but let's do this final stretch to learn something new, possibly. So in this case we want to export it as display. Let's call it display. So if you check your attributes, we will have this mask, which will have all the information we need for the next step. So let's create a VDB from polygons. So VDB from polygons, And I will set it to a low value, but not right now. Let's set it to first to 0.1, and we will set this to density and use world space and fill the interior. Now that I'm seeing this, let me check something in here. Oh yeah, I used for both. It's alright. So fill the interior, and now we will pass two values, two attributes. So first of all, display, and let's call it display, and we'll also pass the sides. So this will be a bit heavy because we are creating three volumes. So as you can see, we have density, display, and sides. It will be a bit heavy. As I told you, this is a bit on the experimental side. So let's select the density, and as you can see, we have these volumes that I want to hide. So that's what I'm doing. It's not deleting, just hiding in the viewport. And now let's create a volume VOP. And what we will do in here, in this case, we will import bind the display, and we will invert it, so with a complement, because in volumes in VDBs, when you have positive values you go in, and when you have negative you go out. So I want to invert, but we will still need to play with the values anyways. So fit range, and we will need a fit range, and test it right now with an add node and a multiply constant to scale down the effect. So let me just organize this and create an add. So this is not pretty. We need to change the multiply constant to 0.05. And as you can see, we are indeed displacing the geometry, but is also creating those ugly edges. So we need to control the effect, and we also need to remove it from the top. So after the fit, we can do a multiply and do another bind and call it sides, import the sides and multiply it. Now it's only affecting the sides. And now we need to play with the values in here. So I'm going to be pretty subtle, I believe. So 0.4, and this one make it negative 1.2. And now we need to increase this, so let's maybe 0.06. We need to introduce some exterior bending. So as you can see, it's much better this way than with the triplanar displays default. And I also want to introduce some cracks or some damage. And for that, I'm gonna copy this setup from here and go in here and paste it. And we need to steal the position from here. And we want to multiply with the sides. Let's duplicate this and connect it in here. Now let's just see the effect in here. So in this case, I didn't change much. Played with the offset. Let me see if I can get the same value. So 40. And let me see the fit range. Maybe I change the well, to have a bit more effect. Play and reduce a bit the overall effect. So let's see both together, and this is the result we have. Now let's just convert these to polygons, and this is the result we have. So a lot of work, and it's okay. I mean, hopefully you learned something new. And before that, we need to blast. We need to blast the other volumes. So let's just select the density and convert. Now it's fine. And to finish it off, I'm just going to increase this quite a bit. Quite a bit in terms of VDB. So 0.0075. And this might take a while. Well, didn't take much. We could increase it a bit more, but that's fine for now. So let's match size. And we will set this to, let's say, max to min. Merge this. And match size. Let's set it to min. Create a null to get rid of that visualization. And I believe I'm not forgetting anything. Maybe we can introduce some soften normals. I also did it in my original file. So yeah, guys, that is basically it. I really hope you have learned something new. I tried to make it as easy to follow as possible. Maybe it wasn't really successful, but if you guys have any questions, please feel free to place them below. And if you want to get access to this file, you can find it on Patreon alongside with this place points HDA. But I'm telling you, you don't need it. You can just use a scatter or just the default behavior or of the RBD material fracture. So yeah, other than that, I hope to see you next time, and thank you for tuning in with me. See you.